Okay, in this video, we are talking about composite figures. So now we're taking all of the ways that we have found surface area, and we are going to go in and put them all together in order to find a particular shape. So we have to think about this particular picture in a logical stance. Okay? So the first thing we have to notice is that, okay, I have a hemisphere. So I need the surface area of a hemisphere. And I also have a cylinder. But the other thing we have to think about is if I were to paint all of this, that's surface area. So I want to paint every side. But if you see here, this circle right here is not going to be painted because the hemisphere is sitting on the cylinder and the cylinder is meeting the hemisphere, which means that I have to come in and subtract that circle 2 times because I have to subtract it from the hemisphere and I have to subtract it from the cylinder. So I'm going to do minus 2 pi r squared, or the area of a circle. Let's write that instead, the area of a circle. So I got to subtract out 2 times the area of a circle. Well, now we go through and we plug in all of our equations. So surface area of a hemisphere was 3 pi r squared, plus the surface area of a cylinder was that perimeter, 2 pi r, capital H for the height of the cylinder, plus 2 pi r squared for the 2 circular bases, okay, minus 2 times pi r squared for the area of the 2 circles. Okay, so now we have everything here. Now, I personally like to go through and try and simplify anything that I can. So, for example, I have 3 pi r squared plus 2 pi r squared minus 2 pi r squared. So, if we look here, I can cancel this guy and this guy because they're both 2 pi r squared, leaving me with just 3 pi r squared plus 2 pi r capital H. Well, now I need to go through and I need to find my radius and my capital H so I can plug the stuff in. Well, if we look here, my radius is 3, which means that up here the radius is also going to be 3. So for the hemisphere and the cylinder, the radius is 3. And my capital H is the length of the cylinder between the 2 circles, which is 15. So now I plug all of that in. I have 3 pi times 3 squared plus 2 pi times 3 times 15. And so I get 27 pi plus 4590 pi, which gives me 117 pi, because these are like terms. They both have pi, so I can add them together. So let's rewrite this so you all can see it a little better. But 117 pi is my answer. Okay, we have one more example in these notes. So if we take a look at this tower here, it says a tower has a total height of 24 meters. The height of the wall is 20 meters. The base is a square with an area of 16. What is the surface area of the tower? Well, there's a lot going on here, so I'm going to default back to what some of y'all have heard me talk about prior, which is answer, where I annotate, notice, find a strategy, plug and do the work, evaluate, and then ask myself, is it reasonable? Okay? So first things first, we annotate the problem since there's a lot going on, and we see we have a tower has a total height of 24. Okay? So if I were to come over to this picture, and if there's not a picture, draw one. But from the top of the tower to the bottom, that is 24. Okay? So from the very top all the way down, 24. Okay? The height of the wall is 20. Okay, so up to here, so from here to here is 20. And then we have a square base, which it's important that we know it's a square because that means all the sides are equal. Okay, all the sides are equal, and it has an area of 16. So we know that the area of a square is equal to 16, which is equal to base times height. Or sorry, not base times height, but side squared is the one we need. Okay? Which means that in order to solve this, I take the square root of each, and I get that 4 is equal to the sides. So I know all of my sides down here are 4, my base and height. Okay? So we've deciphered that, so now we can find the area, or the surface area of the tower. Now, we've done the annotate, so we're good there. Now we have to notice. I noticed that there is the surface area of a rectangular prism plus the surface area of a square pyramid. Okay? But again, notice that we have a face that's not going to be painted because the two shapes are sitting on each other. So I have to subtract out this square that we have in both the pyramid and the rectangular prism. So I have to do 2 minus 2 times the area of a square. Okay? So now we plug everything in. Well, the one thing that we're really struggling with right now is we don't know the slant height of our pyramid. Well, let's plug in our stuff. Let's get our strategies first before we get into that. So surface area of a rectangular prism is that perimeter times height plus 2 times the area of the base. Okay? Whereas for a pyramid, the surface area of a pyramid is plus the perimeter times the slant height plus area of the base. Okay? Oh, divided by 2, sorry. Divided by 2. Okay? But we also need the area of the square, so we're going to subtract 2 times the area of the square, which is 2 times base times height. Now we can plug stuff in even more. We know that the perimeter is all the sides added together, but in our case we have a square, so we can do 4 sides times 4. So if we do this, we have 4 plus 4 plus 4 plus 4, or 16. So we have 6, let's find our P for the rectangular prism. Let's find our H for the rectangular prism, because that's what these are. We need to actually notify them because the parameters could be different. Okay? We need the area of the rectangular prism and the area of the pyramid. Okay? So the perimeter was 4 plus 4 plus 4 plus 4, which equals 16. The big H for the rectangular prism was 20, as we saw here. The area of the base is just base times height. Sorry, base times height, which is also equal to 4 times 4, which is also 16. Okay? Now we move on to the pyramid, which means that the perimeter of the pyramid is going to be the perimeter of the base, which is the same as the rectangular prism, which again is 4 plus 4 plus 4 plus 4, which equals 16. The slant height is a little tricky, so we'll come back to it. And then we need the area, the base area of the pyramid, which was, again, base times height, because it's a square, or parallelogram. Base times height. and it comes out to 4 times 4, which equals to 16. Now let's talk about this slant height, okay? Right now we have this pyramid with a side length of 4, and we know that the height is going to be 4 as well. Okay? The reason I know the height is going to be 4 is because in our picture here we were said the whole tower is 24, but the rectangular prism is only 20. So that means that the pyramid, if I were to do the rectangular prism plus the pyramid equals total height, that means the rectangular prism was 20 plus x is equal to 24. It's a part plus part equals whole problem. I subtract out 20 on both sides, and I get that x equals 4. So I know that my pyramid height is 4. Well, that doesn't super help me because I need the slant height. Okay? That's just the height of the triangle. I need the slant height. Okay? So this is the inside of the triangle, or the inside of the pyramid, sorry. And I need the slant height, which is formed by a 90-degree angle. So I'm going to cut it in half, and when I cut it in half, this bottom piece becomes 2, so now I have 2 and 4, which means that I can use Pythag to find my slant height. So a squared plus b squared equals c squared. We are looking, our goal is the c. So what we're going to do is we're going to plug in stuff, and we're going to have 2 squared plus 4 squared is equal to our goal of c squared, which means that we have 4 plus 16 is equal to c squared. So c squared is equal to 20, and we take the square root of both sides, and we get c is equal to the square root of 20, or 2 square root of 5. Okay? Or if you are looking for the decimal number, we get 4.5 when rounded. Okay? I mean, personally, I'm probably going to use 2 square root of 5 when I actually do this. This will be the one that I'm going to use so that I have the best answer when I calculate. But now we have everything we need, so we can go back up to the top here and plug stuff in. So the perimeter of the, and let's do some black so it stands out a little bit, but the perimeter of the rectangular prism was 16 times 20 plus 2 times the area of the base, which was 2 times 16, plus the perimeter of the pyramid, which was also 16, times the slant height, which was 2 square root of 5, all divided by 2, plus my base, which is 16. Then we subtract 2 times the area of our base, which was base times height, which is 4 times 4. And yes, it's a lot, but that's what happens. So we can simplify some of this. So we get 16 times 20, which is 320 plus 32. Those cancel. Plus 16 square root of 5 plus 16 minus 4 times 4 is 16, 32. If you look here, we have a negative 32 and a positive 32, so those go away. And I'm left with this really fun number of 336 plus 16 square root of 5. And that would be an acceptable answer. You could give me the decimal, but I would take that as well. Okay? And that is how we find the composite area for this particular problem.